probability theory, and the second part is the inference part. Inference basically consists of two parts: estimation theory and the testing of hypothesis. So in estimation, how to estimate the various parameters, what are the properties, what are the methods of estimation, whether it's a point estimation, confidence interval. And the second part is the testing. Testing means if you want to test the mean, variance, etc. So we have to discuss the various types of hypotheses, errors, power of the test, most powerful test. Then there are some standard tests which are commonly used, which are known as the one sample test, two sample tests. So, and these are based on the normal population. So these two estimation and testing of hypothesis are part of the statistical inference. Okay, and the up to joint distribution is the part of probability theory, and this is the connecting part which you can consider intersection between both the things. So this is the whole syllabus, and roughly we will get 36 lectures. Okay, altogether. Usually it is a 3-0 course, 12 weeks in a semester normally we get. So 36 lecture we get. Sometimes due to various holidays and other things, we may get even less, 2-3 lectures. So this is the syllabus. Then coming to the mode of teaching, of course, we are going via online mode. So what I will do, I will share my notes, okay, which is usually given in the previous classes, and I will just show you that what type of things are there. Means the thing actually taught in the class on the A4 sheet of the paper, and which is projected on the screen. So when we take classes here, we have to, if the number of students are small, say 20-30, we use the blackboard. Otherwise, what we do, we use the A4 size paper, and we take a sketch pen, and the way we write on the blackboard, we write on the paper, and it is projected. So that sheet I am having, and it is in a very clear form. You can follow, and I will be teaching from that. Okay, means I will share the notes, and then I will start lecture wise on that. In case of any difficulty, or any confusion or any doubts, I will take a separate sheet and explain on that and scan and upload to you. Okay. The second possibility is that if you come here, say maybe after puja, what we are expecting that the students might be called, the way things are going. So in that case, I'll take some more classes in the classroom, and I will clear your doubts. So till now we don't have that option, so we'll go with this. So last 2 semesters I have been doing this way, and student did not face any difficulty because notes are very clear, derivations are very clear, and if you hear the lectures, you won't face any problem. Only thing is writing and continuously projecting. It is not possible for me because right now my pen is not working, and it is a slow process also. You cannot cover the whole syllabus if I keep writing, and because in the classroom blackboard things are different, but here writing on something and then sharing, it takes a lot of time. So anyway, so this is the syllabus I will upload. So since you have joined the Microsoft team, their course, under the course material, I will share this. Okay, so you don't have to copy and write this. So this is one thing. Now I will share the books. Can you see? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So there are many books which covers both the topics. So the first book is First Course on Probability, by Sheldon Ross. It is mainly focuses on the probability theory. It does not contain the other part, that is inference part. Second is the Introduction to Probability Theory and Mathematical Statistics, V.K. Rohitgi. So this book's a little theoretical based book and cover both the topics, and you will get lot of material from here. But the notations are little clumsy, and usually the statistics student refer this book. But anyway, you can also follow. So once you go through my lecture and notes, then you can follow any book. No, there won't be any problem. Then there is an Introduction to Mathematical Statistics, Horn and Craig. It's also a good book. It covers both the parts. Introduction to Theory of Statistics. It is a book, again contains both the parts. Part is very good, basically testing of hypothesis and estimation theory. Actually, these two topics are vast area, means very vast. The statistical inference, and we usually in our department we offer a elective course on statistical inference. So those who will be interested going into the depth, you may opt in this maybe in the second year, fourth semester. Then there are some more books. Since it is an engineering institution, so we have a courses on probability and statistics for the undergraduate students that we take. The course content is almost same. Of course, we discuss little application, means the problems are engineering oriented. So this is a Montgomery book where proofs you may not find, but material written is in a very good form. Then Introduction to Probability and Statistics by Milton and Arnold. This is also very good book. Then Probability and Statistics for Engineering and Science, J.L. Deore. Basically in all these books, the problems are exercises which are given are related to the engineering and sciences. Okay, rather than simply derive this, prove this. So here the descriptive type of problems are there, and it is more focused toward the engineering. So then there is another book, Probability, Statistics, Reliability, Keying in Computer Science Application. So these are some of the books which you can refer. Okay, so this also I will share. Now, coming to the exams, so hello, can you hear me?
Yes,
Yes,
sir.
sir.
Yeah, there was some problem with this. So regarding the exams in the IIT system, when the regular semester is on, we have mid-semester exam and end-semester examination. So mid-semester, basically it is conducted before just puja holidays, sometimes September end or October beginning. So its weightage is 30 marks. Okay, and the end semester consists of 50 marks, and 20 marks is for test and attendance. So total comes 100. And in a regular way, the grading is done 90 and above excellent, 80 and above A, 70 and above B, 60 and above C, 50 and above D, and above 35 pass, and below that is fail. So this is a regular system. But in an online system, it is not possible to conduct the examination the way it is conducted. So what is done is we have a Moodle system. Have you heard of that Moodle? So in a Moodle system which IIT is providing us for conducting the examination and even loading and uploading of the materials, etc. So we will be conducting examination on the Moodle where the questions will be of objective type nature, numerical calculations, and multiple matching type. Okay, say uh, one particular problem is there and 3-4 parts are there. So 3-4 questions will be there and then corresponding answers will be there, and then you have to match. So the derivation and other parts is your you have to do on your pen and paper, and you will keep with you, and here you will just answer. So we will conduct someday, and just on a trial basis that we will understand. So this is how. So in this system, we will, instead of conducting mid semester and end semester examination, we will conduct basically the 4 tests, 20 marks each weightage. Okay, so one hour roughly we conduct. So and this 20 marks you will be given some assignment which you will carry out, and I will you have to upload that. Okay, so 20 into 4, 1 hour class test. If the things go in an online mode, say suppose you come back here, maybe the end semester will be conducted in a regular fashion. So it is all in a fluid situation. So keeping in mind that things will be online, if it is online in the whole semester, the marking system will be 20 for each class test, and 20 into 4, 80 marks, 20 will be the weightage for assignments and your attendance and other things. Remember that this grading pattern is a relative grading here. Okay. In a normal system, we will have the same, that 90, and but there also the flexibility is there, because if some student in a class the question paper is very tough and nobody is scoring beyond 60 or 70, then we do the relative grading. Or everybody has got more than 80 marks, then we have to do the relative grading. So similar thing we adopt here, because what we have observed in last 2 or 3 semester teaching, that everybody scores very high marks. Say out of 100 marks, everybody scores more than 85 marks. So in that case, we go for the relative grading. Relative grading means if somebody gets 96 and above, we give EX. Another difference of 4 marks, A. So usually the 10% people get EX, 10 to 15%. There are some guidelines are there. So don't think that whosoever gets a very high marks will get the same highest level of grade. So why I am telling you well in advance, because the student generally say that you have not explained the grading pattern in the beginning. So last few years, even in the class also, we explained that what is the system of examination, how the grading will be done, what type of exam will be there, what will be the pattern of the paper. So since in online mode, so we will have objective types, numerical, and matching type. So maybe after 10 lecture, we'll conduct one trial test. So we'll see that. Okay. So this is all about the thing. If you have any question, then you can ask me about anything before we start the regular material. Is it fine? Have you followed everything?
Yes, sir.
Yes, sir.
Okay. Now, this, have you joined with the link or code?
So with the code.
With the code.
Yes, sir.
Okay. So I need not to send the link every week. So because this is the first time, so I thought let me send you the link as well as the code so that you can join. So we have the classes on Wednesday 10 to 11, Thursday 9 to 10, Friday 11 to 12. And any class test, if we conduct, it has to be conducted on any one of these days. Okay, during the class hours. Okay, so that will decide at a later. Because there is some problem of in the Moodle server. So if we follow this, no other person will book that slot. Okay, if your class is there 9 to 10, so if somebody wants to conduct for your another mathematics class course class test, he cannot do it. So that we'll see. Okay, so let's start. The course material I will upload, but just to show you how it will look like. Let me share you. So can you see this?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So the first topic, as I told you, is the probability, and most of you must have done this course in your earlier classes, BSc, and maybe in class 12th also. Nowadays the probability is taught. So that's why we don't spend too much time. Just we spend 3 to 4 hours at the most, and focus on the other thing. So to start with the probability, first thing is the know about an experiment. What is the meaning of the experiment? So experiment word we are familiar. We conduct the experiment, physics, chemistry, in biology, in medical sciences, and many other places the term experiment is used. And you have done also the experiment in physics and chemistry. But here we focus on those experiments where possible outcomes are known. We do not know what will be the actual outcome. Okay, so well in advance you can tell that what will be the possible outcome. Okay, you cannot tell the actual outcome what will be there, but you can tell if you perform this experiment, these will be the possible outcomes. So we will focus on those type of experiment. So simplest example is tossing of a coin. Okay, so in tossing of a coin, what you do, we toss a coin. So coin has two faces, head and tail. Usually we refer, you can have any type of faces, but generally we say head and tail. It's a standard. So we know that when we toss a coin, either head will come or tail will come. Okay, if the coin is unbiased. Okay, unbiased means is that basically equal chance is there for both the outcomes. Okay, say we may construct a coin in such a way that one side it is heavily loaded, that whenever you throw always head comes. Okay, so we are not considering that type of coin. So usually in many experiment or many problems, we start with the wording that we toss an unbiased coin. But by default, if it is not there, then it is clear cut meant that it is a unbiased coin. Similarly, when we toss a die, we have 6 possible outcomes: 1, 2, 3, 4, 5, 6. Okay, so here also unbiased die. So we will not use the word unbiased often, but meaning is same. We can have mixing of two. We can toss a coin as well as a die. So when we toss a coin as a die, so in coin head or tail may come, and on the die any of these numbers may come. So we may have almost 2 into 6. So basically we will have head, if along with the head 1 may come, along with the head 2 may come, along with the head 3 may come, along with the head 4, 5, 6 may come. Then along with the tail, so T1, T2, T3, T5, 6. So there will be 2 possible outcomes, and there is a result in permutation and combination that if one experiment, when you are mixing two things, this throwing up a coin and a die. So here we have 2 and here we have 6. So 2 into 6, 12. So if one particular experiment can be conducted, have m outcomes, another has a n, so m into n. So that result you can watch. Usually we refer the tossing of a coin a word trial. Okay, trial is a word that first trial you throw a die 5 times. So first trial, second trial, third trial, or first throw, second throw, third throw. So a word trial will be often used. Then we have sample space. So what do we mean by sample space? When we put all the outcomes in a form of the set, okay, means 2 curly bracket and the outcomes you put in between. So it becomes a set. So set of all possible outcomes of an experiment is known as the sample space. Okay. It is usually denoted by S, capital S and capital omega. So depending upon the situation, these 2 symbols you will find that they are used. Okay. In some books they may use other symbols also, but basically the idea is that if you enlist all the possible outcomes in the under the code of 2 under 2 curly brackets, and it becomes a set. So set of all possible outcomes of the experiment. Say for example, when we toss a single coin, we have head and tail. This is the sample space. Toss a die, we put all the outcomes together, 1, 2, 3, 4, 5, 6. It becomes the sample space. Tossing of a coin and a die, we put all together. So all the 12 possible outcomes we put together, it becomes the sample space. When you toss 2 dice, you will get 36. Okay. One die has 6 possible outcome, another has a 6. So 6 into 6, 36. So we usually write 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. And lastly, we write 6, 1, 6, 2, 6, 3, 6, 6. So total 36. So this is about the sample space. Then how the event is defined, because when you use the word probability, you talk about the probability of an event. Say you say what is the probability of occurrence of a head? Okay, what is the probability of getting even number when you throw a die? So these are the events. So what is the connection of event with the sample space? Okay, event word we know that it is not necessarily in this experiment. In other places also the event, say bus, a particular bus arrives at a certain stop. That is an event for me in if I consider the arrival of a bus. So the event is a very general word. We have a basically tournaments are event is a very common word we use. Okay, marriage is an event, puja is an event. So we are not concerned about that. Here, event, what is the meaning of the event? Probability of an event we have to find out. So subset of the sample space. Event is nothing but a subset of the sample space, and it is denoted by the capital letter A, B, C. Okay. So event is nothing but subset of the sample space, and we use the specific notation, and that we refer by capital letter A, B, C, D, E, F. Generally, these are the very common letters. They are used to specify the event. So say for example, if I take the experiment, tossing up a coin, tossing up 2 coins. So this is my experiment. Now, when I toss 2 coins, I have a sample space, head, tail, head, tail. Okay. So I have defined the sample space. Now I have to define an event. So event I can define in terms of the language. I say if occurrence of at least one head happens, then I am interested in this type of event. So I will denote occurrence of at least one head by capital letter A. Okay. Now what is A if I translate this into the form of the set? So occurrence of at least one head means either you get head and tail and head, or both the heads. So A will consist of these 3 elements. Okay. HH, ST, which specify that if any one of them occurs, then you can say that A has occurred. So occurrence of A is an event. Okay. An event I have defined in terms of the language which has been converted in the form of a set. Now A is a subset of sample space. Similarly, the complement of this I can write in a set form. So it consists of the single element. Okay. Now, sometimes we use the word simple event and elementary event. Simple event or elementary event, they are the same word. So if a set consists of a single element, then we call it a simple element or elementary event. Say for example, when you toss 2 heads, if I define occurrence of 2 head, occurrence of 2 head means HH. So this is an event because this is also a subset of the sample space. So this event I have denoted by B. So B is basically nothing but simple event. Okay. Tossing up a coin, head and tail, these are the elementary events. Okay, or simple event. Usually the complementary event is denoted by A complement. Sometimes they use the symbol A bar also, depending upon the different books, they use this one also. So complementary event. Then we have a sure event, which is connected with the universal set. Sure event we denote by capital S. So when you toss a coin, certainly either head will occur or tail will occur. We put them together, so that becomes your S. Impossible event is a null set. Okay. Impossible event is equal to null set. Say for example, you toss a coin, head and tail, and if you define the event that what is the occurrence of 2 heads, so it is an impossible event. You cannot have two heads when you toss a single coin. Okay. So impossible event which is equivalent to null set. Okay. Then we have sample space, which could be finite, which could be infinite. If the number of elements in the sample space is finite, we call finite, otherwise it is called infinite sample space. Say for example, toss a coin till you get a head. Toss a coin till you get a head. And if you are interested in the number of trials needed to get a head, because in the very first trial you can get a head. First trial you did not get the head, then you have to perform the second trial. So TH, you may not get head in the first trial, in the second trial, in the third trial you have got. So like this sequence will be there. And you do not know how many trials you have to perform to get the head. So the sample space could be finite, sample space could be infinite. Now, so these are some of the background material. Now, how the probability is defined? Okay. So there are 3 definitions. One is the classical, second one is the empirical, and third is the axiomatic definition. which is known as the modern definition. Okay, so let us start with the classical definition of the probability. So probability of an event. Okay, always we find the probability of an event. And what is event? Event is nothing but the subset of the sample space. And what is sample space? Set of all possible outcomes. Okay, so how do we denote? So first thing is that probability of event A, because we cannot write all the times a long wording, the probability of event A. Okay, in shortcut we denote by P of A, and later on you will see in the geometric definition what is the meaning of this P of A. Basically it is nothing but a set function, and if you go further detail in the measure theoretic approach, then you will find this is nothing but a measure. So we have another concept of defining the probability, which we call the measure theoretic approach. So we have a omega, you must have seen somewhere this omega A P. Omega is basically the universe set of all possible count. This A is a sigma field. Okay, so sigma field, and P is the measure probability, which is defined on this. So how it is defined? Say suppose you consider the set tossing up two coins. Okay, sorry, tossing up a coin. So what will be the possible events? Possible outcomes will be head and tail, and phi as well as S. So sigma field basically it consists of all the events which can be defined. So if time permits, someday I will teach you. Otherwise, you can you have to go through the measure theory course. So there are all those things you will learn. Okay. So we are not going into that because this type of things are usually taught in the probability theory course. Okay. So here we are considering the classical definition. So classical definition, A is a event. So probability of event A, as I told you, is denoted by P of A. Now, how it is defined? It is nothing but the ratio of the two numbers, the numerator M and denominator N. So let us first focus on denominator. Denominator indicates the total number of possible outcomes associated with that experiment. Okay, so N is the total number of outcomes of an experiment. As I told you, in NX, we are considering those experiments where all possible outcomes are known well in advance, except the actual outcome. So denominator is clear. M, the numerator part, which is the number of cases associated or favorable to event A. Okay, because you will be defining event which is a subset of the sample space. So how many outcomes are related to this event, and generally we call number of cases favorable to event A. Okay, so this ratio M by N represents the probability of an occurrence of event A in the classical definition. Say, let us take a simple example. Tossing up a coin, we have a sample space, head and tail. If I define elementary event, say or simple event, if it consists of a single element H, so what is the probability of occurrence of head, which I have indicated by A. So probability of A will be denominator. There are two outcomes, so 2, and here it is 1, so 1, so 1 by. Tossing up two coins, we have already enlisted. These are the possible outcomes. And there are 4. So the event which is defined is occurrence of at least one head. So occurrence of at least one head, by A. Okay, and A will consist of three elements: head, HT, T. So here in this case, according to the classical definition, if I want to find out what is the probability of this event A, so in the denominator there are 4 outcomes, and number of cases related are favorable to A is 3. So probability of this event is 3 by 4. Okay. So similarly, tossing of a die, we have 36 cases. Sum, if I indicates event B, which is nothing but the sum on the face of the die is 7. That 2 die you throw it, and on one die some number will come, another some number will come. So we are interested in those outcomes which will result you the sum 7. Okay. So total number of cases 36. Number of cases related to this sum of the phase is 7. So we may have 3, 4, 3 on the first die, 4 on the second, 4, 3, 5, 2, 2, 5, 6, 1, 1, 6. So there are 6 cases. So 6 by 36, 1 by 6. Okay. So let us start. You might be having another class. So I will upload this material, and from there you can download, and means all the 4 lectures related to the probability are put together. Okay. So whole material will be available to you. So after the class I will upload and you can see. Is that okay?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, sir.
Yes, sir.
Yes, sir.
So any difficulty, anything there, you can always interrupt me, or you can ask in the next class. I will explain you till you are satisfied. Okay, fine. Okay, then I am leaving.
Thank you, sir. Thank you, sir.
Okay, bye.
Hi, Avinash.